Hello everyone, in this video we will be learning how to use UART in STM32 microcontrollers. UART stands for Universal Asynchronous Receiver Transmitter. It's a dedicated hardware module for serial communication, present in almost every microcontroller. UART is being used in many applications like Bluetooth, GMS and GPS. All API offers a set of functions to configure and use UART peripherals in STM microcontrollers. To transmit a sequence of bytes over UART in polling mode, you can use the following provided function. The UART pointer is a descriptor for the specific UART model you want to write to. The size variable is the number of characters you want to send, and the timeout is the maximum amount of time in milliseconds you allow the function to run. To receive a sequence of bytes over UART in polling mode, you can use the following function. The pdata pointer should be the starting position of the buffer or array you want to write to. To transmit a sequence of bytes over UART in interrupt mode, you can use the following function. To receive a sequence of bytes over UART in interrupt mode, you can use the following function. To put this on practice, I suggest we write some code. What do you think? Let's create a program that communicates with your computer using UART. Let's send back to the computer whatever the PC writes. The program should also send a message on startup and should change the state of the red LED every time a message is received. First of all, we need to know where the USB port is connected on STM Nucleo board. Accordingly, with the documentation, it's UART 3 at PD9 and PD8. So we need to configure the UART 3. We want it asynchronous 115,200 bits per second. 8-bit word without parity and 1 stop bit. Do not forget to enable the UART interrupt. How should be the application? We prepared some flowcharts. They are not perfect, so feel free to do better. The main cycle is preceded by the system initialization and the print of the first message. Then we enter the main cycle. We blink the blue LED only to know if the program is running. Then we call the new message function, where we'll get all bytes and set the flags in case we have new data. After the new message runs, we test the flag variable. If it's 0, start the cycle again. If the flag is not 0, we clean the flag, send back all the bytes received, toggle the red LED, and restart main cycle. Because we will be using the reception in interrupt mode, we need to implement a UART callback. In this case, we only need to update the index and reset the interruption. These are the global variables we need in the .c file. We need to set the interruption. We need to implement the callback. Be sure that you increment the index, keeping it inside the limits, and set interrupt again. The new message implementation. Because we want to use printf, we need to redefine the function fputc. If you are using the STM32 IDE, the function to redefine should be other. These are the variables and functions we publish in the .h. This is the initialization code in main. This is the infinite loop. Now you only need to compile the code and flash it to the microcontroller. See you in the next video.